Before we get more into vectors, let's brush the dust off an old topic, the law of cosines. This law relates the three legs in a triangle and an angle, and will prove very useful when formalizing some properties of the dot product. Now, to derive the law of cosines, we need to set up our problem, and we do this by defining our coordinate system. It's important to note that in math and in physics, but especially in physics, it's important how we set up our problem, because it allows us to solve problems much more simply. So, we set the point with the known angle to be at the origin like so, one leg that shares the angle to be along the x-axis. The other leg that shares the known angle will be tilted by that angle above the leg along the x-axis, and lastly our third leg will simply connect the two legs that share the angle as it has to in order to be a triangle. Now, let's label our triangle. The leg along the x-axis will have length A. The leg that's tilted above the x-axis will have length B. The leg that completes the triangle will have length C. The point at the origin will be labeled big C. The point that ends line A will be labeled big B. The point that is at the top of the triangle will be labeled A. And finally, we have theta, which will be the angle at the vertex. With that out of the way, let's mathematically define the locations of the points. We'll start with the simplest, point C, which is as defined at the origin 0, 0. Next, point B is just A units along the x from the origin, making it at A0. Finally, the most complex, point A. This point is B units away from the origin tilted by theta. Thus, using simple trigonometry, point A is B cosine theta horizontally from the origin, and likewise B sine theta vertically from the origin. And not to leave out theta, theta is simply angle ACB. Before we can continue, we need to note some of the rules we will need to derive the law of cosines. First, we will need the distance formula, which you should be well acquainted with by now. The formula simply states that the distance between points 1 and 2 is the square root of x2 minus x1 squared plus y2 minus y1 squared. Second, we will need the Pythagorean trigonometric identity, which is cosine theta squared plus sine theta squared equals 1. Now, let's start solving the problem. So, what is length C? Well, it is just the distance between points A and B. This is why we need the distance formula. As a result, C equals the square root of the square of the difference in the horizontal components of points A and B, which are B cosine theta and A respectively, plus the square of the corresponding difference in the y, which is 0 minus B sine theta. Now let's square both sides. So we have C squared equals A minus B cosine theta squared plus minus B sine theta squared. Now let's expand. C squared equals A squared minus 2AB cosine theta plus B squared cosine squared of theta plus B squared sine theta squared. Well, this looks familiar. We have a cosine squared and a sine squared. Well, this looks like the Pythagorean trigonometric identity. Accordingly, we will factor out b squared from the two terms. So, c squared equals a squared minus 2ab cosine theta plus b squared, and this is so important we'll write it in a different color, cosine theta squared plus sine theta squared. Now we brought our cosine theta squared from here and our sine theta squared from here. Now we'll use a Pythagorean trigonometric identity to write our next step. So, c squared equals a squared minus 2ab cosine theta plus b squared times 1. And for our long-awaited conclusion, c squared equals a squared plus b squared minus 2ab cosine theta. Thank you for watching. If you like this video, hit that like button. If you have any comments, questions, or concerns, leave them below. Remember to click that subscribe button, and as always, see you next time.